Welcome to Lesson 1, Parallel Lines and Transversals. Our objectives today are to identify angles on parallel lines. These are some of the special angles we'll be looking at, something called alternate interior, alternate exterior, and corresponding. We also are going to be looking at vertical angles and supplemental angles, but you've studied some of those. We'll use those, though, to help us to prove that these types of angles are all congruent. Okay, so what is a transversal? A transversal is a line, like the red one below, that intersects lines. Typically, we draw a transversal through parallel lines, but it can also be drawn through lines that are not parallel as well. So what is so special about a transversal? Why do we care what a transversal is? Well, when a transversal cuts or intersects parallel lines, several pairs of congruent and supplementary angles are formed. And that can help us to identify and solve problems on angles on parallel lines. Okay, so let's look at first a set of parallel lines over here on the left. We have these two parallel lines here, and we have a transversal in red cutting through the middle. What happens when a transversal cuts through two parallel lines? Well, notice we have 8 angles that are formed from that transversal. We have 4 up here at the top, and we have 4 down here at the bottom. Another thing is that we can now see that our areas are separated into exterior areas and interior areas. Notice where the interior area is. It's the area in between the parallel lines. The exterior area is outside of the parallel lines, and that's going to be important when we're looking at, and I'll go back to it, alternate interior versus alternate exterior. Notice here that our interior angles in purple and black, I believe, are in between the parallel lines, whereas these are outside of the parallel lines. Okay, so let's look again at a set of parallel lines here that are cut by a transversal. Now, one thing is, how do I know these lines are parallel? Well, number one, it says that line L is parallel to line M. These two straight lines mean parallel. You may also see something like this, a little arrow and a little arrow. If you see 2 lines that have the same arrow, that means those 2 lines are both parallel. All right, let's start off with things we know. Let's look at angle 8. So we are going to look at angle 8. Well, we know that angle 8 right here is going to be congruent to angle 5. And this is how we write congruent. And I use congruent instead of equal because I don't know the measure. I don't know what the measure is, but congruent means still equal. So angle 8 is congruent to angle 5. And how do I know that? I know that because those are vertical angles. And we've already studied vertical angles. So vertical angles that are across from each other like that are always congruent. So angle 8 and angle 5 are congruent. Let's go ahead and mark that. So I'm going to mark that with an angle mark like this. Okay, now let's think about some other things that we might know. Well, we would know that 7 and 6 would also be congruent because those are vertical angles. We know that 1 and 4 would be congruent, and 2 and 3. So those are things we already know. But how can we, say if we know angle 8, find all the other angles, all of the other 7 angles? Well, let's compare 8 and 7. These 2 angles make up a linear pair, right? The parallel line forms a straight angle. So we know that angle 7 plus angle 8 has to equal 180. I've gone ahead and written that down. So angle 8 plus angle 7 here, which we'll mark angle 7 by using 2 angle marks. So that way we know it's different than angle 8 and 5. Okay, angle 7 plus angle 8 has to equal 180 degrees. They're supplementary angles. So if we know angle 8, we can find angle 7. And if we know angle 7, we can find angle 8. Same thing with angle 5 and 7. Well, if angle 7 are these 2 orange marks, then we know that angle 6 also has to be these 2, right? Whatever the measure of angle 7, it has to equal angle 6. So now we can say that angle 7 plus angle 6, oops, what I mean is, sorry, angle 7 is congruent to angle 6. And that is because of the same reason that angle 8 was congruent to angle 5. Those are vertical angles. All right, so we've identified all these angles in one set of our parallel lines here, or in one of our parallel lines, where the transversal cuts. What about these angles up here? How can we find these angles from angles 5, 6, 7, and 8? Well, let me show you this. Let's just say I drew another transversal that was parallel to this one. We'll see how close I can get. Say it looks something like that. Well, we know that this shape here in green is in fact a parallelogram because we have two sets of parallel sides. Well, think about angles in a parallelogram. You probably studied that back in 8th grade. But your angles in parallelograms, we know that adjacent angles have to add to 180. So we know that angle 6 plus angle 4 has to add to 180. Well, whatever the opposite of angle 6 is, to add to 180, would be the same as angle 8 right here. Angle 6 and angle 8 have to add to 180 as well because, again, that's a straight angle. So we can say then that angle 4 right here is going to have the same measure as angle 8. Angle 4 and angle 8 are congruent. Now our reason is not going to be because it's inside of a parallelogram because we just drew that. That doesn't exist. The reason is going to be because these are corresponding angles. Think about where they lie on the parallel lines. Look up here at this blue and gray one. Angle 3 and angle 7 are in the same location on each of their parallel lines. Just like 1 and 5 are in the same location, and 2 and 6 are in the same location, and 4 and 8. So anytime you have angles that are in the same location on the other parallel line, those are considered corresponding angles because their location corresponds to the other location on the other end. So if we continue to use that logic to name our angles, then we could also say that angle 2 up here corresponds to angle 6. So I could say that angle 2 is congruent to angle 6, and again, because those are corresponding angles. So make sure in your notes that you're writing down this example so that you know what are corresponding angles. That's a new term for you. Well, let's continue with that logic. We just did angle 2 and angle 6. Well, what does angle 7 correspond to up here? Hopefully you said angle 3. Do that one in orange as well. So angle 3 corresponds to angle 7. And again, it's because of the same reason they're corresponding. Okay, we have one set of angles left to look at, and that's angle 1. Well, we already know that angle 1 and angle 4 are going to be congruent because those are vertical angles, but how about compared to 5, 6, 7, and 8? Well, angle 1 corresponds to angle 5 right here. So we know that angle 1 and angle 5 are going to be congruent because of corresponding angles as well. And I'm just going to put CA for corresponding angles. Okay, so if we go back to our original objectives, we see that we have identified corresponding angles. The angles here in pink correspond, the angles in blue correspond, the angles in maroon correspond, and the angles in black correspond. What about alternate exterior and alternate interior? Well, if we go back and look at our diagram, our alternate means alternating on either sides of the transversal. So if we are looking at alternate interior, we can only look at these 4 interior angles, 3, 4, 5, and 6. Well, which ones alternate? Well, 4 and 5 do. Look at our diagram. 4 and 5 are congruent. Come back over here. 3 and 6 alternate, and they're both on the interior. So 3 and 6 are also congruent. So we could say that angles 3 and 6, angles 3 is congruent to angle 6, and this is due to alternate interior angles, and I'm abbreviating that as AIA, alternate interior angles, but you would want that in your notes as well. Okay, what about 4 and 5 then? So 4 and 5 are also congruent for the same reason, and that is due to alternate interior angles. Okay, so going back to our original diagrams, we only have two sets of alternate interior angles. The two angles that alternate on either side of the transversal, and they're on the interior. What about alternate exterior? Well, it's exactly the same principle, except they alternate on the outsides of the parallel lines, not on the interior. Notice where the pink is and notice where the blue is. So again, if we go back to our original shape here, our exterior angles are 1 and 2 and 7 and 8. So if we look at our diagram, 1 and 8, those alternate on either sides of the transversal and they're on the exterior. So we could say angle 1 is congruent to angle 8, and that is due to alternate exterior angle theorem. And we also have 2 and 7. Notice 2 and 7 were congruent in our diagram, so angle 2 is congruent to angle 7, and again by the same theorem, the alternate exterior angle theorem. Okay, so let's recap. Why are we learning all these different ways to identify angles? And the reason is because we don't really know what we're going to get. So if we can find relationships between all these angles and parallel lines, we can help to identify and solve problems within parallel lines. So remember, we have alternate interior, alternate exterior, and corresponding angles. Okay, let's conclude by filling these angles out here on this parallel line. So we have two parallel lines, and all we know is 52 degrees. Well, let's start figuring things out. Okay, let's make a list of all the angles we have. So we have angle 1, so these are our angles, and we'll go ahead and solve them. We have angles 1, 2, 3, 4, 5, 6, and 7. Okay, go ahead and pause the tape and see if you can figure out what these angles measure. All right, if you're coming back, let's go ahead and give it a try. So angle 5, we know, is a vertical angle to 52. So we know that angle 5 is going to equal 52 degrees. And let's put the reason. We said vertical angles, so we're going to say VA. And I'll go ahead and write the 52 here. If you write in what you know, it's easier to keep solving. Okay, let's go from there. Well, I know that angle 1 and angle 52, they correspond. They're in the same location on each of their parallel lines. So I know that angle 1 is going to be 52 degrees. And the reason I'm using there is corresponding angles. And there could be multiple reasons depending upon what you find. Well, that means that angle 4 has to be 52 degrees. And what is the reason there? Well, it's just like the first reason. That's a vertical angle to angle 1. Okay, let's keep going. Let's look over here at angle 2. What is angle 2? Well, angle 2 is supplementary to angle 1. So if I take 180 degrees and I subtract 52, I should get what angle 2 is. So angle 2 would be 128 degrees. 128 plus 52 should give me the 180. So I'm going to say that angle 2 is 128, and that is due to supplementary angles. So I'm going to say SA. Okay, let's make it a little bit trickier now. Let's try to find angle 7 using a different theorem. We could use angle 7 and 5 and say supplementary, but let's go ahead and look at angle 2 and angle 7. We know that those are alternate exterior. So I'm going to say that angle 7 is 128 degrees due to my alternate exterior angle theorem. And I'm going to write in here 128. Great. All right. Let's look at angle 6 and angle 2. Those are corresponding angles. So angle 6, we know, also has to be 128 degrees. So I'm going to write 128 here. Those are corresponding angles. Okay, now let's use the alternate interior theorem. We haven't used that yet. So what is angle 6 and angle 3? Those are alternate interior angles. So I know that angle 3 also has to be 128 degrees. And my reason is alternate interior angles. Now I've found all my angles. Some of these I found because I've looked at the congruent pair. Others I found by finding the supplementary angle. I could have also found 4 and 6 using supplementary angles as well, because remember, these two are supplementary. Okay, that concludes our lesson today on parallel lines and transversals. So hopefully at this point you are now able to identify the different types of special angles on parallel lines, including our 3 new ones: alternate interior, alternate exterior, and corresponding. Hopefully though, you will still recognize when we have vertical angles or supplementary angles.